fellow Badgers. My name is Gwendolyn Johnson, and you have found yourself tuning into UW Today. Today, we have 3 freshman researchers from the University of Wisconsin-Madison. They are coming to talk about their research on whether or not nanoparticles are a probable and efficient way to deliver drugs to humans. Let's welcome our first guest, Justin Marciano. Can you give myself and the audience some background information on your research and tell us what a nanoparticle is?
Sure. So a nanoparticle is basically any particle that's between 1 and 100 nanometers in size. So these particles are used in many scientific fields such as agriculture, electronics, space, and also medical therapeutics, which is our main question today. So our final research question was, are nanoparticles a good way to efficiently deliver drugs to humans? And basically, in medicine, nanoparticles are more specifically used for nanomedicine. So this is this almost microscopic delivery of drugs inside your body using these lipid-based particles in order to deliver efficiently.
That was great information. Thank you for that. We're going to bring in our second guest, Austin Gavigan. What are some significant findings that you have discovered through your research on nanoparticles?
So first, just to start off, there are 3 types of drug-delivering nanoparticles that are based on solid lipids, and that is the solid lipid nanoparticle, SLN. They have good physical stability, controlled drug release, tolerable. However, they have a high water content, so nanostructured lipid carriers and lipid drug conjugates were formulated to overcome some of the defects of SLNs. Basically, to determine if a nanoparticle will cross a biological barrier, surface charge is observed, which is what we're hoping to do. And particles with a cationic surface charge are more likely to interact with cells and increase the rate of internalization. And it can be difficult to direct the particle to a certain body system and prevent it from reacting with something else that you don't want it to react with. They have to be made very synthesized specifically to only react with certain cells. One example is ceftriaxone. CFT is currently a major drug for ocular infections, but it degrades quickly in aqueous solutions like inside the eye. So conventional eye drops require high concentration and frequent installation of the drug to achieve what it's attempting to achieve. But after that specific, just some highlighted advantages would be that nanomedicines are better than traditional medicines in general because they're better at targeted delivery since they're smaller. They're better at controlled release, and they, in general, have a greater therapeutic impact on the patient, and they can minimize side effects, which is better than, again, drugs currently, and they have made it so that lower dosages of that actual drug is required because it can target the tissue specifically.
Wow, that was very informational. I'm sure the audience has learned a lot.
Thank you.
Sadly, we're coming to our third and final guest after this commercial break. Thank you.
This broadcast is brought to you by Gordon's Dining Hall.
Welcome back to UW Today. We are going to be bringing in our final guest of the evening, David Clark. Austin just gave us some insight on the advantages of drug-delivering nanoparticles. Have you discovered any disadvantages?
Yeah, there are a few. So in some cases, the smaller the nanoparticle is in size, the more toxic it becomes, and this is because it has a greater surface area to volume ratio, which means it's more reactive with whatever it is it's reacting with. And there's still a lack of knowledge as to what they can do, and it could be unpredictable and potentially hazardous on certain tests. So to conclude what I have said and my other researchers have said, although nanoparticles in general have been around for quite a while, we're still only scratching the surface of what they can do in relation to human health. we have much more research to come to discover what those benefits or disadvantages could be. And the research looks extremely promising, so we're really hopeful for what the future of this field has to bring.
I'm sure our managers are hopeful as well. Thank you to Justin, Austin, and David for visiting the studio today. We'll see you next week on UW Today.